Delivering government services to a population of 1.4 billion people is a massive logistical challenge. With 22 official languages and wildly diverse socioeconomic realities, a single one-size-fits-all administrative approach quickly breaks down. India has already laid the groundwork to reach these citizens. If you look at the street level of almost any Indian city, you will see payment QR codes everywhere. These networks, along with digital identity systems, make up India's foundational digital public infrastructure. But establishing a digital identity and a way to pay only gets you halfway there. If a user cannot read the text on a government portal, or if a local administration is still processing paper claims by hand, that digital connection hits a wall. To solve this friction, the government cannot simply buy commercial, off-the-shelf artificial intelligence from a foreign tech company. Those models are typically trained on Western data, mostly in English, and they are not designed to navigate the highly specific local dialects and administrative hurdles of the Indian subcontinent. Overcoming this delivery bottleneck at a population scale requires upgrading the entire digital infrastructure with an indigenous intelligence layer, an autonomous system built specifically for the actual realities of the people using it. This diagram illustrates the India AI mission. You have the foundational block of existing digital infrastructure, the payments and ID systems, and directly on top, a new interconnected intelligence layer being built to run the ecosystem. The mission is structured around 7 pillars. A major focus is establishing a high-end computing ecosystem within the country, alongside the development of domestic foundation models. These include large language models and domain-specific small language models, trained strictly for Indian use cases. By embedding these capabilities directly into the state architecture, artificial intelligence shifts from being a commercial product sold by private companies into a state-managed public utility. One of the sharpest bottlenecks in this system is language. When critical health information or government data is only available in English or Hindi, millions of citizens are locked out of the services they need. This diagram maps out how the government's Digital India Bhashini division solves this. A user speaks a regional dialect into their mobile interface. The Bhashini API processes that audio, translates it, and sends the data to a central government server. It handles text-to-voice and voice-to-voice conversion across 22 official languages in real time. As seen here at the UNICEF India 75th anniversary event, institutions are deploying this technology at scale. Bhashini integrates into platforms like UNICEF's Rapid Pro, allowing health workers to disseminate critical medical information in the specific languages their communities actually speak. For millions of citizens, the internet transitions from being an exclusionary, text-heavy hurdle into an accessible, voice-first ecosystem they can easily talk to. This grid visualizes 762 problem statements across 62 ministries. Zooming into the healthcare sector, we isolate the Catch Initiative, an AI diagnostic pipeline for cancer screening. Panning to the security sector reveals the CyberGuard hackathon, training models to classify cybercrime for the National Reporting Portal. India is systematically crowdsourcing intelligence to digitize, optimize, and automate its vast bureaucratic machine. Deploying autonomous technology across 1.4 billion people carries extreme risks. Synthetic media, bias in decision-making, and identity fraud can destabilize public trust and institutions overnight. The European Union tackled AI risks by passing a rigid, comprehensive law. India rejected that monolithic approach, calculating that heavy, preemptive legislation would crush domestic innovation before local startups could even build their models. Instead, they are making targeted legislative tweaks. The government amended existing IT rules to combat synthetically generated information, forcing platforms to explicitly label AI-generated content and deploy measures to verify and remove malicious fakes. This visualization compares the two regulatory strategies. On the left, a rigid, monolithic block representing hard law shatters against a rapidly evolving problem. On the right, India's soft law approach operates as a dynamic hub. It relies on existing statutes like the Digital Personal Data Protection Act for privacy, while empowering individual sector regulators, like the central bank or the securities board, to issue flexible, targeted guidelines. Because the technology evolves faster than traditional legislation can be drafted, this sector-specific agility offers a safer and far more effective way to govern artificial intelligence. The resulting strategy relies on a dual-engine approach: massive state-backed infrastructure development to build the technology, paired with agile, decentralized regulation to keep it safe. To ensure the system remains locally controlled, the government is establishing data and AI labs in Tier 2 and Tier 3 cities. This distributes research grants and fellowships, keeping the human talent pipeline sovereign and deeply rooted in the country. By embedding intelligence directly into its public infrastructure, India provides a blueprint for the Global South. It proves that artificial intelligence can function as a universal public utility, an engine for inclusive, population-scale transformation.